Now here the question is, X and Y are two weak students in mathematics and their chance of solving a problem correctly are 1 by 8 and 1 by 12. So probability that X solves the problem correctly is 1 by 8 and Y solves the problem correctly is 1 by 12. Now it says they are given a question and they obtain the same answer if the probability of common mistake is 1 upon 1,001, then the probability that answer was correct is A upon B, where A and B are co-prime. Then find the value of mod A minus B. Now let us consider two events. Event E1, when both of them they solve correctly, and then this event E2, when both of them they solve incorrectly. Now this probability that both of them they'll solve the question correctly, it is given by this probability of X into probability of Y, since they are solving the problem independently. So this probability will be 1 by 8 into 1 by 12. So it will be 1 by 96. And the probability that they'll solve the problem incorrectly, it will be this Px naught into Py naught. Now Px naught is 7 by 8 and it is 11 by 12. So there will be 77 by 96. Now let A be the event that their answers match. Now if both of them they have solved the question correctly, then the probability of their answer matching will be 1. But if they have solved the problem incorrectly, then probability of their answer matching, it is given by 1 upon 1001. Now we need to find the probability that their answer was correct, given that they obtained the same answer. So basically it's a problem of Bayes theorem. So we have to find probability that their answer was correct, given that they have a common answer. So we'll take this case in the numerator. So it will be this 1 into 1 by 96 upon 1 into 1 by 96 plus 77 by 96 into 1 upon 1001. Now this 96 will cancel. Now 77 divided by 1001 is 13. So this probability will be 13 by 14. And that's your A upon B. Now modulus value of A minus B is simply 1, and that is the answer to this question.